Regular buildup and hard surfacing of the shear is important for performance and long shear life. For maximum shearing efficiency, all edges of the shear jaws should be kept square with the blades and saber tip. Check the upper and lower shear every 80 hours and maintain it when necessary. Normal intervals for hard surfacing will vary depending on the amount of wear and the application. After blade maintenance has been completed, begin with the upper jaw and determine if buildup is required. For the blade seat area, place a straight edge across the blades and look for gaps along the blade seats. If buildup is needed, clean all dirt and grease from the area to be maintained and remove all existing hard surfacing by grinding down to the base metal before beginning the buildup. Following the manual's guidelines, preheat the work and surrounding area to a minimum of 400 degrees Fahrenheit, 200 degrees centigrade, and a maximum of 450 degrees Fahrenheit or 230 degrees centigrade. The temperature must be uniform throughout the material thickness and maintained until all welding has been completed. Check the temperature often and do not overheat the material, as this can harm the shear. Install the welding ground directly to the upper jaw to eliminate the possibility of welding current passing through the hydraulic cylinder or the main pivot group shaft and bearings. Now, apply single passes of E7018 welding rod or E70 series wire to build up the worn areas. Note, do not weld in the apex area. Each pass must be peened vigorously to relieve weld stress and remove slag. Once built up, grind all edges to 90 degrees in line with the blades. Next, establish the pattern for the hard surfacing beads. These beads should run parallel to the blades from behind the saber tip to approximately the midpoint of the primary blade. Depending upon the size of your shear, 3 or 4 beads will be sufficient. Check for proper material temperature and reheat if necessary. Do not apply hard surfacing directly to the parent material. Use E7018 welding rod or E70 series wire as an underlayment, applying single passes and peen after each pass to remove slag and relieve stress. Keep the outside passes at least a 1/4 inch, 6 millimeters, back from the blade seat and outer edges. Stagger the ends of the welds and do not end a weld adjacent to a blade bolt hole, and do not weld up into the throat area. With the pattern established, apply a single layer of Amaloy 814H or equivalent hard surfacing welding rod on top of the pattern. See your manual for proper hard surfacing rod specifications. Again, peening after each pass to remove slag and work harden the weld. Once the pattern has been completed, use a grinder to taper the ends of each weld down to the base material, being careful not to undercut the welds. Grind so that the grind marks are parallel with the grain of the steel. When welding is complete, wrap the welded areas in heat blankets and allow it to cool slowly to the ambient temperature before returning the shear to service. For the front of the upper, place a straight edge along the blade sides and use the upper build-up template provided by La Bounty to determine the proper profile. Use a grinder to clean the area and remove any existing hard surface material. Following all the proper welding procedures, preheating to a minimum of 400 degrees Fahrenheit, 200 degrees centigrade, and a maximum of 450 degrees Fahrenheit or 230 degrees centigrade. Apply single passes of E7018 welding rod or E70 series wire to properly build up the area. Peen after each pass and grind edges square. Note that when properly built up, the upper face should protrude 1/16 of an inch beyond the edge of the saber tip and secondary blade. Once the buildup is completed, it will be necessary to hard surface the front of the upper to protect it from excessive wear. Allowing 1/16 of an inch from the edges, create a diamond or crosshatch pattern of approximately 1 1/2 inches, 40 millimeters, by applying single passes of buildup, E7018 rod or E70 wire, peening after each pass. Again, this serves as an underlayment for the hard surface beads. Do not apply hard surface directly to the parent material. Apply a bead of Amaloy 814H or equivalent hard surfacing welding rod on top of the pattern. It is important to use an air-operated slag peener on each pass to relieve weld stress. When welding is complete, wrap the welded areas in heat blankets and allow to cool slowly to the ambient temperature before returning the shear to service. The lower wear plates protect the lower crossplate from excessive wear. Inspect these plates every 80 hours and replace them before they wear away and allow the crossplate beneath to become worn. When it is time to replace the lower wear plates, preheat the wear plate area to the proper temperature, 400 degrees Fahrenheit or 200 degrees centigrade, and maintain the preheat temperature throughout the process. When air arcing or welding on the lower jaw, install the welding ground directly to the lower jaw to eliminate the possibility of welding current passing through the hydraulic cylinder or the main pivot group shaft and bearings. Air arc the old wear plates to remove them completely from the crossplate. Use a grinder to make the surfaces flat and smooth. Remove all weld and carbon air arc residue. If necessary, build up the edges of the crossplate before installing the new wear plates. Position the larger of the two wear plates so it is centered across the front of the crossplate. The holes in the wear plate should be aligned with the holes in the crossplate. This should leave a gap between the top of the wear plate and the top of the crossplate that will be filled with weld later. Clamp the wear plate into position and tack weld in place. Using E7018 welding rod or E70 wire, weld an approximate 3/8 inch or 10 mm fillet around this wear plate, peening after each pass. Also, weld a fillet around the inside of the holes on the front. Position the smaller wear plate so it is also centered across the top of the crossplate. This wear plate should overhang the front edge of the crossplate to be flush with the face of the front wear plate. Use a straight edge to position it and clamp it in position long enough to tack weld it in place. Start by filling the area between the wear plates. Then weld an approximate 3/8 inch or 10 mm fillet on all remaining sides around the wear plate. Stress relieve each pass by peening and grind the weld smooth. For maximum performance and long life, all outer edges of the lower shear should be built up as needed. Check the lower shear every 80 hours and maintain it when necessary. All blade maintenance should be done before performing building up and hard surfacing the lower. Clean all dirt and grease from the area to be maintained and remove all existing hard surfacing by grinding down to the base metal. Use a straight edge to determine how much buildup is required on the crossplate. Use the straight edge across the top of the blades to find the buildup requirements on the top side of the lower shear. All edges should be square. When ready for welding, preheat the area and maintain the proper temperature throughout the welding process. With the lower shear grounded, apply buildup to the worn areas in single passes, side by side, running with the grain of the base metal. Peen each pass to relieve weld stress and remove slag. Grind all edges to 90 degrees. If necessary, build up the area beneath the edge of the secondary blade so it is flush with the blade. The blade should not stick out beyond the edge of the blade seat in this area. However, do not weld in the apex area. To hard surface the top sides of the lower shear, establish the pattern with 3 or 4 beads. Keep the outside beads at least a 1/4 inch, 6 mm, back from the blade seat edge and the outer edges. These beads should run parallel to the blades from the crossplate back to about the midpoint of the primary blade. Do this on the guide blade side also. Check the material temperature and reheat if necessary. Using E7018 rod or E70 wire, apply single passes, peening after each pass. Be sure to stagger the ends of the welds. Do not end a weld adjacent to a blade bolt hole or weld into the throat area. Apply a bead of alloy 814H or equivalent hard surface rod on top of each of the underlayment beads. It is important to use an air-operated slag peener on each pass of weld to relieve stress. When all the beads have been covered, use a grinder to taper the end of each weld down to the base metal, but be careful not to undercut the welds. Using proper welding technique, the sides of the crossplate should be hard surfaced with a diamond or crosshatch pattern. When welding is complete, wrap the weld areas with a heat blanket and allow to cool slowly to ambient temperature before returning the shear to service.